Good morning. Non-deterministic finite automated mission. So this journal can be written as Yanni Yafie. Yanni Yafie. So here this is the transition diagram for the Yanni Yafie. So when the system is in the state Q0 and input 0 is applied to the state Q0, then the system moves to either Q0 or Q1. So either Q0 or Q1. So thus some moves of the mission cannot be determined uniquely by the input symbol and the parent and the present state. So the system is this type of system is known as non-deterministic finite automaton. So here we observe when the system is in the state Q0 and input 0 is applied, then it moves to two states. So that is either Q0 or Q1. So this type of system is known as NDFE. So complete definition of non-deterministic finite automaton. It is a 5-tuple Q, sigma, delta, Q0 and capital F, which is similar as finite automaton. So here Q is the set of states and sigma is set of inputs and delta is the transition function from Q plus sigma to 2 power Q. And Q0, which belongs to capital Q, is the initial state and capital F is the set of final states. And next, acceptability of a string in a finite automaton. So it can be written as delta of Q0W, which is contains some final state. So this is known as acceptability of a string in a finite automaton. So, example, check whether a string 0100 is accepted by NDFE. So here the transition diagram, and here the states are Q0, Q1, Q2, Q3, Q4, and the initial state is Q0, which is the circle along with the arrow mark, and the final state is Q4. So Q4. So now check if the system is at this state Q0 and input 0 is applied to the state, then it moves to Q0 or either Q3. So either Q3. So when system is at the state Q0 and input 0 is applied, then it moves to Q0 or Q3. And again, next thing is 1. So when input 1 is applied to the state Q0 and it moves to either Q0 or Q1 or Q1 and less than 0. Again, 0 is applied to the state, and then it moves to Q naught R Q 3. Q 3. And that's 0. When the state moves to 0, then it moves to Q naught R Q 3. So now we can note the final stage. So when 0 is applied to the state Q3, then it moves to the final state. Then it moves to the final state. Then it moves to the final state. So here the acceptability of the spring is Q0 to Q1. So Q0 to Q0 and Q0 and Q3 and Q4, which is the initial state and it is the final state. So this is the out of the string, out of the string 0 1 0 0 0 1 0 0. So when we observe here, we can't get the final state. Then we applied 0 to the state Q3, then it moves to the final state. So this is the correct part to the string 0 1 0 0. So all we have to that of Q0 W which contains some final state. So final state will then acceptability of the string data. So here final state only Q4. So that is this is the right part to the string 0 1 0 0. Now we see the equivalence of DFA and NDFA. The term is for every NDFA, there exists a DFA which simulates the behavior of NDFA. Or here L is the language. So if L is the set accepted by NDFA, then there exists a DFA which also accepts the language L. So now we start the proof. Let capital M is equals to Q sigma delta Q naught and capital F be given NDFA and L be the language accepted by NDFA. Now we construct DFA, that is deterministic finite automated. It can be written as M dash, Q dash, sigma, delta dash, Q dot dash, and capital F dash. Here we denote M dash to vary from M and Q dash vary from Q, delta dash vary from delta and similarly. But the inputs are same in both the states. So both in the both cases sigma remains same. So please note that point. So the inputs are same, but the states and the transition functions and final states will vary. So we denote M dash, Q dash, delta dash, Q naught dash, and F dash, which is equivalent to given ND, yes. So now first one, the Q naught. So in NDFA, the transition function. Transition function. Transition function delta mapping from q cos sigma 2 power q. Thus, it has more than one transition Fourier input symbol. Input symbol in a state. Earlier we have seen that in the transition graph when 0 is applied to the state q dot and it moves to q dot and q1. So those type of systems are at the DFA. Whereas in DFA, all these states must be remembered. Hence, the states in DFA becomes subsets of Q. That is, Q dash is Q naught. Q power of Q. Q power of Q. Then the second one, the initial state in NDFA is Q naught, whereas in the initial state in DFA is Q naught dash, which is also written as Q naught. So please note this notation. And third one, the final states in capital M, that is NDFA, are capital F, whereas the final states in M dash, that is in DFA, are F dash. So we explain Q dash and Q naught dash, capital F dash, and the remaining is delta dash. So the fourth one is the transition function. So now we define the transition function delta dash in M dash has delta dash of Q1, Q2 and so on, Qi and A, which is can be written as delta of Q1A union delta of Q2A union so on delta of Q1A are equivalently delta dash of Q1, Q2 and so on QI, and J, which is conventional has E1, E2, and so on. EJ, which is if and only if, then of Q1, Q2, so on, Qi, comma A is equals to the set of E1, E2, and so on. E, G. E, G. Now we said, so that, now we show that, no, we show that, and DFA, and DFA, and DFA, and DFA accepts the same language. Accepts the same language. So for this we prove, an auxiliary result, then others of Q naught dash of x is equals to Q1, Q2, so on, Qi, if and only if, then R of Q naught comma x is equals to Q1, Q2, so on, Qi for all x in sigma star, which is equation number 1. So, we prove this result by mathematical induction, on the none option, on the none of the on the none of the so the necessary part of so we prove the necessary condition of equation 1. So that is we prove that we have to prove that the address of Q naught dash x is equals to Q1, Q2, so on, Qi, if then of Q naught comma capital X, small x is equals to Q1, Q2, so on, Qi. So that now the length of the string is 0, that is empty string. So that is the empty string. So then R of Q naught comma x is then R of Q naught comma empty string, which is equals to Q naught. So which is property 1. Property 1 we have explained in the previous video. Similarly, the address of Q naught dash of x is equals to the address of Q naught of sigma lambda is equals to Q naught dash, which is the initial state in the F, and which is the initial state in and the F. Hence, the result is proof for the strings of length 0 of length g. So now assume that the result is true for all strings whose length is less than or equal to small m, that is that of the string less than or equals to small m. So let's be a string of length m plus 1. Sorry, it's some small mistake, that is length less than or equals to, okay, that's here, then x is equals to y, where y belongs to input symbol sigma. So now let z of q0 comma y, which is equals to E1, E2, so on, E, Z. E1, E2, so on, E, Z. So this one. So that of gamma is equals to P1 of P2, E, Z. The same thing. That of Q0 y is equals to E1, P2, E, Z. Then a dash of Q0 dash of y is equals to E1, E2, so on, E, Z. Similarly, then a dash of Q0 a, which is equals to P1, P2, E, Z. So let that of Q0 x is equals to that of Q0 y, yeah, which is equals to that of Q0 y, yeah, which is equals to some string R1, R2, and so on, Rk. So now, so here R1, R2, Rk are some notations. So R1, R2, and so on, Rk is that of Q0 y, yeah, which is equals to that of Q0 y comma, yeah. Similarly, that of Q0 y means the set of E1, E2, and J, E, J, comma, yeah. So now, by definition of delta dash of E1, E2, so on, Ez, comma, yeah, which is equals to R1, R2, so on, Rk. Hence, delta dash of Q0 dash y, which is equals to delta dash of Q0 y, comma, y, which is equals to delta dash of, so delta dash of Q0 y is equals to set of E1, E2, E. So that delta dash of Q0 dash of y is equals to E1, E2, so on, E, Z. So which is equals to R1, R2, so on, Rk. Hence, the result is hence the result is true for all lead strings. For all lead strings. Now we use a sufficient condition. Sufficient condition for equation 1. So now x belongs now x belongs to E of M that is the set of strings accepted by M. Accepted by M. If and only if del of Q naught comma x contain some final state. Contain some final state. So now from the above result, we get del of Q naught x contains state of capital M. If and only if del of Q naught comma x is in F dash. Therefore x belongs to EM dash. So therefore L is equals to E of M is equals to E of M dash.